Hello, what we're going to look at is queues today. Okay, so I'm going to be using the PowerPoint and the notes that you've got. Don't forget you've got those questions as well, exam questions, which I'll need to check on Teams for what you've got to do on those. Right, so let's open up the PowerPoint and make a start. Right, now it is a FIFO data structure. Now, everyone's aware of a queue. Unlike a stack, a queue is something that you will do every day, possibly. So it's FIFO, first in, first out, which kind of, it's a fair system. Unlike a stack that would be unfair if you had to implement that in any sort of situation where you would be wanting to get served, for instance. Anyway, so now to implement a queue, you need some variables, right? So you can see I've got an end, front, current size, that S is short for, and the maximum size down there. All right. So I've got front, end, size, max. Now, adding items to the queue. Now, we all know that we add items to the end of the queue and you join at the end. Okay. And we remove stuff from the front. So what I did then was I added one to our end pointer and then put the item where the end pointer is. So if I add another one, add one to the size, I move one to the end. So currently that's our steady state, all right? So our front is Andy, our end is Bob, and our current size is 2. Then I've added somebody else, and I can add Dave there, and the size is 3, and adding somebody else again, right? So, and then I add finally there, right? So, okay, so we've filled up our queue. We can't add any more because the current size is equal to the max, and then we take people off. Now, who comes off? Well, it's the front comes off, so it's Andy comes off the queue. Now, I didn't have to remove him. I just did it to make it clearer, okay? And then we add one to our front pointer, and I reduce the size down to S. And I could take Bob off, he would come off next, and so forth. And the size is now 3, and our front pointer points to number 3. Now, high-level pseudocode for removing and adding items. Now, let's have a look at that. So first off is we have is size adding. If size is not equal to max, then we go ahead, add one to E. So we add one to our end pointer, and the queue at E equals item. Now that I would have normally done square brackets there. That's the old Visual Basics array symbol there. But okay, add one to my size. Removing, again, if size isn't 0, so they can't remove anything if it's empty. Item equals the queue at the front. We add one to the front, and that should be size equals size minus 1, but it's plus. In your notes, I've got it right, okay? So just bear in mind. I can never find that one. I always forget every year. Now, right, the problem is if I carry on with these algorithms, then what's going to happen is I add one to E, that would fall off the end of the array, that would cause an error. Out of bounds for my array, and that's not good. Now what I could do is like a supermarket, we shift everybody up one, so every time someone remove them from the queue, everybody shifts up one, so everyone's at the front. Now that would be okay for small queues, but if that was a lot of items in the queue, then that's going to take a long time to do. Now the other option is using the circular queue. Now that is the one we're going to go for. Now, so a circular queue is simply this. If I want to add something to the queue, well, I add one to E. But then when E falls off the end, rather than trying to put it at E, I wrap it round to the beginning. All right, so E goes to the beginning now. And then I can put my item there and then add one to S, and that's all good. If I add another one, it's still fine because the size is 4. Then I add one to E, put the item there, and so forth. Right, so our size is now 5, our max is 5, I can't add any more. I can certainly take people out though. So it looks a bit odd because our end is in front of our front, but It's fine. Just remember, Dave will be the next one off if someone wants to leave the queue. So Dave is next. So we take him off. Again, I could have left him there, but it makes it a bit easier to see. And then I add one to, so remove one from the size, and there we go. And then I move up to there. So again, now so our size is currently 3, which is fine. If I want to take the next person off, which is Ray, Ray can come off. Add one to F. F falls off the end. So if it falls off the end, we make it equal to 1, and size is now 2. So that's all good, isn't it? That looks much nicer than it did before. Now, the pseudocode. Now, this one, all it basically is exactly the same as before, except we have this if statement here. So we say if E is greater than max, then we make E equal to 1. All right. And then removing, notice I've got the right size on this one. And again, if the front, because it's the front that's moving on this one, then we make, if it falls off, if it's greater than max, then we make it equal to 1 again. And that's all good. Now, so that's all it is for that. So it's not a massive amount. It's not like the recursion one. Now the notes has a little bit more. So it want you to write in the pseudocode. Actually, I've done it for you. Now notice I've that's a plus there that I've just overwritten with a blob to make it like a minus sign. But the other bit that was important is this priority queue, which is not on the PowerPoint. Now, priority queue, it works in the same way, except that some items will have a higher priority. So we have our queue in this state, so we have broken arm, grazed knee. So now someone now joins with a heart attack. Now, if they were placed at position 3, that would hardly be fair because, you know, they're going to die possibly. So then we can move them to the top of the queue. Okay. So, and then suddenly someone comes in now with severe concussion, which is worse than a broken arm, but not like as bad as a heart attack, apparently. So how could we implement that? Well, one is you'll just search through your existing queue and put their item there, or you just add it to the end, and then when you take someone off the front of the queue, then you do a search first. So lots of different ways of doing it. There isn't a priority queue implemented in C#, so it is a bit of a pain. Now, look out for Teams. There will be questions on what you need to do. Now, you do have this little exercise here. Whoops. Yeah, this one here. I don't know what I've called that done, but it's not. So this is using a circular queue. They will always tell you if you're using a circular queue or a linear queue. And that's really it. I mean, it is pretty much straightforward. Obviously, the exam questions, not that common, but we'll talk about in class in terms of the frequency of these sort of questions. Okay, that's queues done.